When you hear the words mass extinction, what's the first thing that pops into your head? Probably dinosaurs, right? See, that dinosaur extinction, the one that happened 66 million years ago, is called the KT extinction. And yeah, it was a big deal, but it's just one of 5 major extinction events in Earth's history. Scientists call them the Big Five. 5 times life almost got completely wiped out. And the KT extinction, it's not number 1 on the deadliest list, and not number 2 either. There's actually one that was way more intense. It hit long before the dinosaurs, long before mammals, even before plants figured out how to grow tall. It's called the Late Ordovician mass extinction, and it's like the horror story no one ever tells. Just this insanely powerful event that nearly emptied the oceans and left life gasping for air. In this video, we are going to look into it. What happened, and how close did Earth come to hitting the reset button for good? All right, to understand how bad things got during the Late Ordovician mass extinction, we first need to look at the world before it all went downhill. We're going back around 486 million years to a time called the Ordovician period. Back then, Earth was basically a giant water world. Imagine endless oceans, scattered with a few lonely islands here and there. No continents like we know them today, just small land masses floating like stepping stones across the sea. Oh, and sea levels? They were way higher. We're talking up to 2,000 feet higher than today. That's taller than the Burj Khalifa underwater. The climate was hot, humid, and super tropical. Think sauna, but planet-sized. And for marine life, that was paradise. Now don't expect much if you went walking on land. It was a snooze fest. The only thing you'd see would be some early plants, small, simple ones like mosses or liverworts. No trees, no grass, no animals. Just soggy rocks and little green fuzz. But the water was a whole different story. Beneath the waves, life was exploding in every direction. Coral reefs were just getting started, building the first big underwater cities, homes for an explosion of alien-like sea creatures. There were the endocerids, which were massive shelled cephalopods, more like giant squid inside bullet-shaped tubes, stretching up to 30 feet long. These were the apex predators of the day with sharp beaks, powerful tentacles, and a bad attitude. They ruled the ocean floor. Then there were the trilobites, not scary but wildly successful. Think of them as the ancient cockroaches of the sea, found everywhere, in every size and shape, doing everything from crawling along the seabed to swimming near the surface. And if trilobites weren't careful, they'd end up as lunch for sea scorpions, also called eurypterids. These things were like prehistoric tanks with claws. Some were small, others grew up to human size, and many were probably cannibals. Yeah, eating their own kind. There were also the conodonts, freaky, eel-like creatures with big, buggy eyes and microscopic razor teeth. Their teeth were so sharp, some scientists say they're the sharpest of any animal ever, and they were only 1/12 the width of a human hair. Then you've got the radiodonts, the weirdos of the sea. They look like props from a sci-fi movie. Some were hunters, others filtered food from the water, and a few were just floating nightmares with eyes and limbs in all the wrong places. This wasn't just an ocean, it was an alien ecosystem. A thriving, complex, surreal underwater world full of strange creatures doing strange things. But here's the twist. In a world that seems so alive, something was quietly building in the background, a chain reaction that would soon wipe out nearly everything. And it all started with the sky. Now here's where things get unexpected. While all that bizarre sea life was thriving below the waves, something strange was happening in the skies above. Scientists studying rocks from the Ordovician period started noticing an unusual amount of L-chondrite meteorites, a specific type of space rock, embedded in ancient layers. There were so many of them, it didn't seem like a random event. It hinted at something bigger, something cosmic. One theory suggests that around this time, a massive asteroid, possibly hundreds of miles wide, got torn apart by Earth's gravity. The pieces didn't just fall and vanish. Instead, they may have formed a ring system around Earth. Yeah, like Saturn. Imagine looking up and seeing shimmering rings circling the sky, reflecting sunlight during the day and glowing softly at night. Earth, for a brief moment in its history, might have been wearing jewelry. And that wasn't all. For the next 40 million years, Earth was bombarded by frequent meteor showers, way more than we get today. This period is called the Late Ordovician meteor event. Instead of a shooting star once in a while, you'd see dozens, maybe hundreds every night. Blazing fireballs streaked across the sky, lighting up the clouds, mirrored perfectly in the calm, shallow seas below. It would have been breathtaking, beautiful, and even romantic if not for what was coming. Because while it all looked magical, there was a sense of danger building behind the curtain. These weren't just pretty lights in the sky. The increased meteor activity meant Earth was constantly under fire. Each impact stirred up the environment, shaking ecosystems, shifting climates, and possibly even helping trigger what came next. And as those alien oceans shimmered under a sky full of falling stars and silent rings, life continued, unaware that its golden age was about to end. Next up, the cold came, and it came fast. Everything changed around 445 million years ago. Until then, Earth had been a humid, tropical paradise, at least under the sea. But almost without warning, the planet began to cool. Fast. Temperatures dropped sharply across the globe. And suddenly, the oceans that once nurtured alien ecosystems began to turn against them. This sudden chill triggered one of the most extreme and mysterious ice ages in Earth's history, the Hernantian glaciation. And it wasn't just a bit of snow. We're talking glaciers that stretched into places like modern-day Africa, South America, and even parts of North America. The formation of these massive ice caps had an immediate and devastating effect. Sea levels crashed, falling by as much as 410 feet. Imagine coastlines disappearing, reefs being left high and dry, and shallow marine ecosystems, where most Ordovician life existed, suddenly vanishing. Coral reefs, which had just started to flourish, were wiped out almost overnight. Creatures that lived in or around those reefs had nowhere to go, and many simply couldn't adapt in time. And as the ice expanded, it drew moisture and warmth away from the atmosphere, pushing the world into an even deeper freeze. What made things worse was that the cooling created a dangerous feedback loop. As glaciers spread across the land, they exposed large areas of rock and soil, material that naturally absorbs carbon dioxide from the air during weathering. This process pulled even more CO2 out of the atmosphere, making the Earth colder still. For marine life, this was a nightmare. The shallow waters where biodiversity once thrived became too cold, too dry, or just disappeared entirely. Ecosystems collapsed and food chains fell apart. Among the hardest hit were entire groups of marine creatures. Brachiopods, which looked like clams but weren't actually related, were decimated. Echinoderms, starfish relatives, suffered massive losses. Trilobites, those armored sea bugs that had once ruled every corner of the ocean, started to disappear in shocking numbers. And bryozoans, colonial organisms that built reef-like structures, took one of the worst hits of all. These animals had survived for millions of years, but the ice didn't care. And as if habitat loss wasn't brutal enough, the oceans themselves started turning deadly. Scientists believe that deep waters experience something called anoxia, a dangerous drop in oxygen levels. Without enough oxygen, even the simplest life forms can't survive. Entire layers of the ocean may have turned into lifeless zones, especially in deeper regions where cold water sank and trapped carbon, sulfur, and other toxic compounds. In short, it wasn't just that animals had nowhere to go. Even the water they swam in had become poisonous. But nature wasn't done delivering gut punches. Some studies suggest that during this chaotic time, mercury began leaking into marine systems, likely from volcanic activity or the disturbance of mineral-rich seafloors. Mercury is extremely toxic, especially to small creatures at the bottom of the food chain. Once they started dying off, the ripple effect spread upward. Bigger animals starved. Some turned to cannibalism, others simply vanished. It was a slow-motion collapse across nearly every level of the marine food web. And just when life might have started adjusting to the cold, the climate started flipping again. Warmer periods popped up in short bursts during the Ice Age, not warm enough to heal the planet, but just enough to confuse everything. Animals that had adapted to freezing temperatures suddenly found themselves overheating. Eggs hatched at the wrong times. Food sources came and went, unpredictably. It was a game of survival with ever-changing rules, and most species were losing. In the end, this first wave or pulse of extinction was like a slow, squeezing vice. No asteroid, no instant shock. Just a long, drawn-out decline caused by freezing seas, shrinking habitats, suffocating waters, and toxic poisons. The oceans, once full of life, had become hostile. The world was no longer warm and full of color. It was turning gray, still, and silent. And tragically, this was only the beginning, because after the ice reached its peak, the second wave hit. When the dust settled, the ocean was quiet. Coral reefs had vanished. Apex predators like endosaurids were gone. Countless families of brachiopods, trilobites, and conodonts disappeared, some never to return. What was left was a fractured version of the thriving, alien ocean world that had once dominated Earth. But surprisingly, life didn't stay down forever. Some creatures would bounce back, others would rise for the first time. The stage was now set for evolution to take a very different path. When the waves of extinction finally settled, the world looked nothing like it did before. Scientists estimate that between 49% and 60% of all marine genera were wiped out during the late Ordovician mass extinction. And remember, back then, almost all life was marine. So this wasn't just a bad day for coral or trilobites. This was Earth getting punched in the gut twice. Up to 87% of all marine families were lost. That's a bigger percentage than what vanished during the Great Dying, the extinction that came much later and is often called the worst in history. Recovery didn't come quickly. It took anywhere from 5 to 20 million years before marine ecosystems began to stabilize again. That's longer than the entire existence of the human species, by the way. Some creatures managed to hang on and adapt. Others completely vanished from Earth, leaving behind nothing but fossils and questions. Evolution had to restart the engine from scratch in many areas. And even when life bounced back, it looked very different from what came before. Let's break it down by group, starting with the biggest losers. First up, the endosaurids. These were the giant shelled cephalopods, the apex predators of the Ordovician seas. They didn't make it. Once rulers of the deep, they disappeared entirely during the extinction. From that point on, no cephalopod would ever dominate the food chain the same way again. Next, the trilobites. These creatures were everywhere before the extinction. Successful, adaptable, and incredibly diverse. But they were hit hard. Nearly half their families vanished. And although they survived the extinction itself, they never returned to their former glory. Their numbers kept dwindling in the ages that followed, until they finally went extinct for good during a later extinction event. And then we have the sea scorpions, or eurypterids. These were the strange, often terrifying predators that lived in a variety of marine and brackish environments. Somehow, they pulled through. In fact, they didn't just survive, they thrived in the aftermath. With many of their competitors gone, they quickly expanded into new environments and became one of the most dominant animal groups in the Silurian period that followed. Echinoderms, which include modern-day starfish and sea urchins, had a rough time during the extinction. They lost around 70% of their genus, a massive blow. But against the odds, they bounced back. As new shallow seas formed during the warmer climate of the Silurian, echinoderms adapted quickly and found new niches to fill. Their recovery was surprisingly fast, and they became important parts of the restructured ecosystem. Brachiopods, though, not so lucky. These filter-feeding creatures were once incredibly diverse and abundant, but the extinction hit them especially hard. Not only did most species die off, but those that survived were weak, small, and scattered. This downsizing phenomenon is known as the Lilliput effect, when surviving species shrink in size after a mass extinction, likely because of limited resources in harsh conditions. Even today, the brachiopods that are still around are just a shadow of what they used to be. As for the conodonts, those creepy eel-like creatures with microscopic razors for teeth, their story was a mixed bag. Some lineages died out, but others slowly recovered over time. It took them an entire geological period to bounce back, but they eventually did, peaking again much later. Early fish followed a similar path. They were still in their early stages of evolution during the Ordovician, and while they didn't dominate, they were affected. Like the conodonts, they didn't become major players again until the Devonian, which is often called the Age of Fishes. So by the time the extinction ended, the oceans weren't just quiet, they were scarred. Coral reefs were gone, predator-prey systems had collapsed, entire food chains had to be rebuilt from the ground up. The oceans of Earth had become a post-apocalyptic wasteland, filled with smaller, struggling survivors trying to make sense of a changed world. But as always, life didn't give up, and now comes the question that still baffles scientists today. What could have caused all this? So after two massive extinction waves, oceans drained of oxygen, and whole groups of creatures gone forever, the big question is, what caused it all? That's the part that still puzzles scientists to this day. Unlike the dinosaur extinction, Where we've got strong evidence of a single asteroid, the late Ordovician event doesn't have one neat and tidy answer. Instead, there are multiple theories, and each one gives us a different piece of the puzzle. Some are backed by strong science, others are more speculative, but all of them point to one uncomfortable truth. Sometimes, Earth just breaks. One of the first ideas is pretty straightforward, a geographic shift. During the Ordovician, a huge landmass called Gondwana began drifting toward the South Pole. As it moved, the land got colder, ice started forming, and glaciers began spreading. This fits with the timing of the Ice Age we talked about earlier. The idea is that once Gondwana was close enough to the pole, it triggered a planet-wide cooling event that spiraled out of control. But here's the catch. Continental drift is slow. Tectonic plates move at about the speed your fingernails grow. So while Gondwana's positioning might have helped set the stage, it's not enough to explain how quickly the Ice Age hit. The suddenness of the freeze suggests that something else had to push Earth over the edge. That brings us to the leading theory, volcanism, or more simply, a whole lot of volcanic eruptions. Now, we usually think of volcanoes causing global warming, right? Eruptions release carbon dioxide, which traps heat. That's what likely happened during the Permian extinction, much later. But in the Ordovician, it might have been different. Instead of CO2, some volcanoes, possibly from what is now modern-day Iran, may have released enormous amounts of sulfur dioxide into the atmosphere. Sulfur acts like a reflective shield. It blocks sunlight, cools the planet, and can cause a rapid drop in global temperatures. In this case, it might have been enough to kickstart the Hernantian Ice Age. So while tectonic movement moved the pieces into place, volcanoes might have pulled the trigger. There's even a sub-theory that suggests the eruptions briefly caused a warming event before things collapsed into a full-blown freeze. Either way, volcanic activity is still the front-runner for what caused the chaos. But that's not the only suspect. In the early 2000s, some researchers proposed a more cosmic idea, a gamma-ray burst. That's basically when a distant star explodes in a massive supernova and sends a powerful beam of radiation across space. If one of those beams hits Earth, even for just 10 seconds, it could strip away the ozone layer. With no ozone, ultraviolet radiation from the sun would blast Earth's surface, frying any life exposed to it. Marine creatures living near the surface or in clear water would be especially vulnerable. Now let's be clear, this is a controversial theory. There's no direct evidence of a gamma burst hitting Earth during the Ordovician, but it could explain how the Ice Age started so suddenly. Radiation could have triggered chemical reactions in the atmosphere, changing the climate almost overnight. It's a terrifying idea, and while not widely accepted, it's still on the list of possibilities. Speaking of terrifying, another theory involves a giant asteroid impact, possibly one even bigger than the one that killed the dinosaurs. In 2023, researchers in Australia discovered something strange underground, a buried circular structure called the Deniliquin multiple ring feature. Based on its shape and size, it might be the largest impact crater ever found on Earth, with a diameter of over 520 kilometers. That's almost 3 times bigger than the KT impact crater in Mexico. If this really was caused by an asteroid, it would have released more energy than anything Earth had seen before, easily enough to trigger an ice age, block out the sun, or send climate systems into chaos. But here's the thing, it's still unconfirmed. Because it's buried deep underground, scientists haven't been able to prove for sure that it was caused by an impact. So for now, it's a giant question mark, with world-ending potential. Another theory takes a more down-to-earth approach, literally. It suggests that plants might have played a role in the extinction. Around this time, the first land plants began to spread across Earth's empty continents. As they did, they pulled carbon dioxide out of the atmosphere during photosynthesis, just like plants do today. But back then, CO2 levels were key to keeping Earth warm. So as plants grew and multiplied, they may have helped tip the planet into a deep freeze. It's a surprisingly simple explanation, but it actually fits well with what we know about the timing. And then there's the wild card. Remember those rings around Earth we talked about earlier? Some researchers have suggested that these rings might have cast huge shadows, reducing sunlight in certain parts of the world and possibly affecting global temperatures. Now, this one's a long shot. There's no solid proof it happened. But it's a good reminder that when it comes to deep time, nature doesn't always play by rules we understand. The truth is, we still don't know exactly what caused the late Ordovician mass extinction. It might have been one big thing. It might have been several smaller events stacking up over time. Maybe a volcano started it, an ice age took over, and an asteroid or algae bloom delivered the final blow. Or maybe something we haven't even discovered yet was the real culprit. What's clear is this: the scale of suffering was massive, and survival came down to pure luck. The species that made it through didn't do so because they were the strongest or smartest. They just happened to be in the right place at the right time. The late Ordovician mass extinction may not get the attention of the dinosaur-ending asteroid, but in many ways, it was even more devastating. It reshaped the oceans, toppled entire ecosystems, and erased more marine families than even the Great Dying. And while there's still mystery surrounding exactly what caused it, we know enough to be both awed and alarmed. This wasn't just an old disaster buried in rocks. It was a glimpse of how quickly Earth can shift beneath our feet. Yes, nature recovered. It always does, eventually. Life found new forms, new paths, and new survivors. But recovery took millions of years. Entire species came and went during that healing period, which raises a haunting question for us today. If another mass extinction is unfolding now, will we still be around when the world recovers? If you found this story as fascinating and unsettling as we did, hit that like button, drop a comment with your thoughts, and share this with someone who's never heard of the Ordovician extinction. Let's bring this forgotten chapter of Earth's history back into the light. And of course, don't forget to subscribe for more deep dives into the strange, wild, and untold stories of our planet.